Here we have to graph a quadratic function. The way you know it's a quadratic function is because it's in the form of f of x equals x minus h squared plus k, where we have the highest power is a 2, and it's in vertex form for a quadratic function. So this equation here, this is the vertex form. We need to use this to get the vertex. The vertex is hk. For h, what you want to do is just take the number and flip the sign when you put it into the vertex parentheses. So you take that 3 and you flip the sign. This is only something you have to do for h. You put k directly into the parentheses and you keep the same sign for k. So just to summarize, h you flip the sign, the 3 became negative 3, and for k you keep the sign, the 4 stayed positive 4. We needed the vertex, and we need at least 2 other points to at least do a rough sketch. Here's how you can do it. You can make a little table where you have x. On the bottom, you'll just say that the x plus 3 squared plus 4 is equal to y. We really only need 3 points in general. You can go up to 5 points if you want. We start with the vertex, negative 3, 4. So this is where you want to start. From here you go left or right. What if you go to the right? Whatever distance you go right, you want to go the same distance left. So if you go 1 unit to the right, this would be negative 2. And for the vertex, you say that this is y, and you plug in the x that we just picked. This is negative 2 plus 3 squared plus 4. Inside the parentheses, that's 1. Then you square it. Then you add 4. 1 squared is 1. Plus 4 makes that 5. So as an ordered pair, we have the vertex, which is where we should start. Then here we have another ordered pair. X is negative 2, y is 5. Now, if you go the same distance left that you go right, which in this case you go 1 to the left, meaning you subtract 1 from negative 3, and you get negative 4. And that means that the negative 4 here will have the same y-coordinate as the negative 2 because of the symmetry of the quadratic function. And so with the negative 4, you could always check. You could still plug it into the equation and make sure you got the same y-coordinate. This will be negative 1 squared. And negative 1 squared is 1, which makes this 5 when you add the 4 to it. From the negative 2, you go 1 more unit right. Or if you want to think about it from the vertex, now we're going 2 units to the right. So basically you're adding 2 to go to the right here. That means that if you add 2, this is negative 1. And so we'll find out what the y-coordinate is here by plugging this in. So you put the negative 1 where the x is. Here this is 2 squared plus 4. Then that makes this 4 plus 4, which means this is 8. So when you have negative 1, the y-coordinate is 8. And going back to the negative 3, the vertex, you want to go the same distance left that you go right. So for this one, we went right by 2 from the vertex. So now you want to go left by 2. Subtract 2 from the negative 3, and that's how you get negative 5. And you plug this in, and then you simplify this. This becomes 4 plus 4, which means this is 8. And so you see the y coordinate is the same as the other one when it went 2 to the right. So that's when we can check that you have the right y coordinate. So we have the vertex and 4 supporting points. That's everything we need to graph this. Draw a rectangular coordinate plane, and then we'll start with the points. The first one you want to plot is the vertex. This is -3, 4. Let's say this is -3, and this is 4. So the vertex would be here. After you plot the vertex, you can go in any order. You can go and do the right ones or the left ones, but you can plot the rest of these in any order. So this is -2, this is 5. The next point is here, going to the right. Then this is -1, and this is 8. So there's another point over here. That takes care of the 2 on the right. Here's the first one on the left, -4, 5. And this is the second one on the left. We have the -5, 8. So this is how you can sketch a quadratic function. For this, do you have any questions about anything?
No questions.